Welcome to a deep dive, into some news that has the potential to, like reshape the world as we know it.
Yeah.
Quantum computing.
Yeah.
Specifically, Microsoft's just made this like giant leap forward,
Right.
unveiling the world's first quantum processor powered by something called
Oh, wow.
topological qubits.
That's right.
Our sources today lay out not just what this is, but like why it could be the key to unlocking applications that sound straight out of science fiction.
Yeah, that's an exciting part.
Right.
What's so intriguing here is that Microsoft claims to have created a new type of matter,
Oh, wow.
a tokenductor.
Okay.
This was previously only a theory,
Mhm.
and it's the foundation for their entire approach.
So before we even get to the computer itself,
Right.
they've already broken new ground in materials, science.
Yes, exactly.
Color means intrigued.
Yeah.
What exactly is a tokenductor?
So it's essentially a hybrid material
Okay.
combining the properties of a semiconductor and a superconductor.
Okay.
In this case, Microsoft used indium arsenide,
Mm-hmm.
a common semiconductor, and aluminum,
Uh-huh.
a well-known superconductor,
Okay.
at extremely low temperatures and under precisely controlled magnetic fields.
Okay.
They created this new state of matter.
Okay, I'm trying to picture this.
Yeah.
They basically engineered this topoconductor atom by atom,
Right.
which is mind-blowing in itself.
Absolutely.
But how does this lead to a quantum computer?
Well, this new material allows them to create and control something called Majorana zero modes, or MZMs.
MZMs.
Yeah, you can think of these MZMs as the heart of their quantum computer
Okay.
because they act as the qubits.
Now, you've used the word qubit a couple of times
Oh,
for our
right.
listeners who are new to quantum computing.
Mm-hmm.
Can you quickly recap what a qubit is and why it's so special?
Sure. A qubit is the basic unit of information in a quantum computer.
Okay.
Like a bit in a classical computer.
Mhm.
But unlike a bit, which can only be a 0 or a 1, a qubit can be both at the same time through a concept called superposition.
Okay.
This, along with another quantum phenomenon called entanglement,
Mm-hmm.
is what gives quantum computers their incredible power.
Okay, that's the quantum magic we've all heard about.
Right.
But one thing that's always baffled me is how fragile these qubits seem to be.
Yeah.
Isn't maintaining their stability a huge challenge in the field?
That's precisely where these topological qubits based on MZMs could be game-changing.
Okay.
See, the quantum information in an MZM isn't stored in a single point,
Okay.
but in a non-local way across the entire nanowire.
Uh-huh.
This makes them far more resistant to environmental noise and errors,
Right.
a problem that has plagued other types of qubits.
So these topological qubits are like the super resilient superheroes of the quantum world.
In a way, yeah, you could say that.
That makes a lot of sense.
Yeah.
But how do they actually build a computer with these things?
So Microsoft has laid out a fascinating roadmap.
Okay.
They've created a basic building block called a tetron,
Tetron?
which is basically a pair of topological superconducting nanowires
Okay.
connected by a perpendicular non-topological superconductor.
Hold on, why this specific design?
Yeah.
It sounds kind of Tetris-like.
Yeah, it's a clever design choice.
Okay.
Because it allows them to scale up the system.
Okay.
Each tetron holds a single qubit,
Right.
and they can simply connect more tetrons together to create larger and larger arrays.
Right.
Think of it as snapping together Lego bricks to build a massive quantum computer.
Okay, that's starting to click for me.
Good.
So they've got these stable qubits in their tetron block.
Right.
But how do they control them and read the information stored within them?
Yeah,
That seems incredibly delicate.
it is. And this is where it gets even more impressive.
Okay.
To read the information without disturbing the qubit's delicate state,
Mm-hmm.
they've turned to something called quantum dots.
Okay.
These are tiny islands that can hold a single electron.
Wow.
By coupling these dots to the ends of the nanowire and then using microwaves,
Uh-huh.
they can measure the dot's charge, which reflects the state of the qubit.
That's incredible. They're basically bouncing microwaves off these tiny islands to figure out what the qubit is doing without actually touching it.
Exactly.
It sounds like some seriously advanced engineering.
It is, and they've achieved a remarkable error rate of just 1% with this measurement technique.
Wow.
They've also shown on their system is extremely stable,
Okay.
with qubits maintaining their state for relatively long periods.
Mm-hmm.
These achievements lay the groundwork for moving to the next stage of their roadmap.
This is all very impressive, but they've only demonstrated a single qubit so far, right?
That's right.
What's next on their roadmap to a million-qubit computer?
Their next goal is to create a 4x2 tetron array,
Okay.
which will give them 8 qubits to work with.
Okay.
With this larger array, they can start exploring more complex quantum phenomena like entanglement
Okay.
and test out the basic principles of quantum error correction.
Entanglement error correction, it sounds like we're diving deeper into the quantum rabbit hole.
Yeah,
But before we go further, I'm curious about something.
sure.
We've been talking a lot about Microsoft's approach,
Right.
but I know there are other players in the quantum computing game, right?
Oh, absolutely.
What are some of the other big names and how do their approaches compare?
So some big names you've probably heard of are IBM and Google.
Mm-hmm.
They've been focusing on a type of qubit called a superconducting transmon qubit.
I've definitely seen those mentioned in the news, but how do those work and how do they differ from Microsoft's topological qubits?
So transmon qubits are essentially circuits built with superconducting materials.
Okay.
They're relatively easier to manufacture using existing semiconductor techniques.
Right.
However, they're also more susceptible to noise and errors compared to topological qubits.
So it's like a trade-off.
Right.
Easier to make, but less stable.
Exactly.
Microsoft's gone for the harder to create, but potentially more robust qubit with their topological approach. Makes you wonder if this announcement might shake things up in the field.
Yeah, for sure.
Could other companies shift their focus towards topological qubits now that Microsoft has shown it's possible?
It's certainly a possibility.
Yep.
This breakthrough could trigger a new wave of research and investment in topological qubits.
Right.
It's a bit like a challenge to the rest of the field, showing that there are multiple ways to reach the goal of a large-scale, fault-tolerant quantum computer.
It's exciting to see this kind of competition heating up almost like a quantum space race.
I agree.
But let's zoom out a bit
Okay.
and come back to what all this means for the average person.
Right.
We've touched upon self-healing materials and sustainable solutions.
Yeah.
But what are some other areas where a million-qubit quantum computer could make a real difference?
So the possibilities are vast,
Yep.
and we're only just beginning to scratch the surface.
Right.
One area that stands out is drug discovery and development.
Okay.
Imagine being able to accurately simulate the interactions between molecules. This could revolutionize how we design new drugs.
Right.
Yeah, making them more effective and reducing side effects.
That would be a game changer for the pharmaceutical industry and for everyone who relies on medication.
Absolutely.
What about personalized medicine?
Yeah.
Could quantum computers help tailor treatments to an individual's unique genetic makeup?
Absolutely. With the ability to analyze vast amounts of genomic data,
Right.
quantum computers could help pinpoint specific genetic mutations that cause diseases
Okay.
and develop personalized therapies that target them directly.
Wow.
It could revolutionize healthcare as we know it.
This is starting to sound like the future of medicine is being rewritten with the help of quantum mechanics.
In a way, yeah.
What other industries could see a dramatic transformation?
Finance is another prime candidate.
Okay.
Quantum computers could enable far more sophisticated risk management models, optimize investment portfolios,
Right.
and even detect fraudulent activities with an accuracy we can only dream of today.
So not just better healthcare,
Right.
but a potentially more stable and secure financial system.
That's
The
right.
implications are truly profound.
Absolutely.
But I'm curious,
Yeah.
with all this talk about million-qubit computers, what are the current limitations?
Right.
What are the major hurdles that researchers still need to overcome?
So one key challenge is scalability.
Okay.
While Microsoft has laid out a roadmap, actually building a million-qubit computer is an incredibly complex engineering feat.
Right.
They'll need to perfect the manufacturing process for these tetrons,
Okay.
ensure they can be reliably connected, and control them all with precision.
It sounds like they're essentially trying to build a microscopic city on a chip
Yeah, a good analogy.
with millions of interconnected components, all working in perfect harmony.
Exactly.
Another significant challenge is error correction.
Uh-huh.
While topological qubits are inherently more stable, they're not immune to errors.
Right.
Developing robust error correction techniques is crucial for building a reliable quantum computer that can tackle real-world problems.
Absolutely.
Okay, so scalability and error correction are two of the biggest hurdles.
Yeah.
Are there any others?
The development of quantum software is another major challenge,
Okay.
often overlooked but equally important.
Right.
We need new programming languages and algorithms specifically designed to harness the power of quantum mechanics.
Right.
This is a whole new frontier of software development.
It's like having this incredibly powerful engine, but not knowing how to build a car around it.
A perfect analogy.
It's exciting to think about the possibilities, but also a reminder that there's still a long road ahead before quantum computers become mainstream.
Indeed. However, the pace of progress is accelerating, and the excitement surrounding quantum computing is palpable.
Yeah.
There's a sense that we're on the cusp of a new technological revolution, and Microsoft's latest breakthrough adds fuel to that fire.
It's definitely a journey we'll be following closely.
Yeah.
Speaking of journeys, I can't help but wonder about the timeline for all of this. Microsoft has been a bit vague about specific dates.
Yeah.
But do they have any targets for when we might see some of these incredible applications become a reality?
So they haven't given specific dates,
Right.
but have hinted that they're aiming for a fault-tolerant prototype within a few years
Okay.
as part of their agreement with DARPA. It seems like the million qubit goal is still quite a way off.
Right. But even with a prototype,
Yeah.
what kind of impact could that have?
So even a smaller scale fault-tolerant quantum computer would be a huge milestone.
Okay.
It would allow researchers to start testing out more complex algorithms
Right.
and get a better understanding of the practical challenges of quantum computing. This would pave the way for those larger scale systems and those real-world applications we've been discussing.
So it's like a stepping stone.
Yeah.
A crucial proving ground before we reach those million qubit dreams.
Exactly.
It's all starting to feel very sci-fi, but in the best way possible.
I agree.
And it makes me wonder,
Yeah.
what are the areas where we might see the earliest impact?
Right.
Where could even a prototype make a difference?
So one promising area is materials science.
Okay.
Even a relatively small quantum computer could help us simulate the behavior of molecules with much greater accuracy than is possible with classical computers.
Right.
This could lead to the discovery of new materials with properties we haven't even imagined, like those self-healing materials we talked about earlier.
Okay, now I'm picturing a future where our clothes repair themselves after a tear, or our houses fix cracks before they even become visible.
Right.
It sounds like something straight out of a superhero movie, but this is actually becoming a potential reality.
It is, and that's just one example.
Right.
Another area where we could see early progress is in optimization problems.
Okay.
Imagine using a quantum computer to design more efficient logistics networks, optimize traffic flow in cities,
Right.
or even develop new financial algorithms that minimize risk.
So basically anywhere where there are complex systems with a lot of variables, quantum computers could come in and find solutions that we humans would never be able to discover on our own.
Exactly.
It's like having a superpowered brain that can see patterns and connections that are invisible to us.
A great way to put it.
And as these quantum computers get larger and more powerful, the scope of problems they can tackle will only expand.
Absolutely.
We're talking about a fundamental shift in our ability to understand and manipulate the world around us.
A very fundamental shift.
This all sounds incredibly exciting.
Yeah.
But I also have to ask, are there any potential downsides to this technology? What about the ethical implications?
So it's crucial to be mindful of the potential risks as quantum computing advances.
Okay.
One major concern is the impact on cybersecurity.
Right.
Quantum computers could potentially break the encryption algorithms that protect much of our online data, from financial transactions to personal information.
That's a sobering thought. So as we develop these powerful tools, we also need to be thinking about how to safeguard against misuse and protect sensitive information.
Absolutely.
It's like a race against time. We need to build the safeguards before the technology falls into the wrong hands.
We do, and we need to be proactive in developing new encryption methods that are resistant to quantum attacks and establish ethical guidelines for the development and use of quantum computers.
Okay.
This is not just a technological challenge, it's a societal one that requires careful consideration and collaboration.
It's a reminder that with any powerful technology, there's always responsibility to use it wisely and ethically.
Couldn't agree more.
But on a more positive note, there's so much potential for good with quantum computing.
Absolutely.
It's like a door opening to a whole new world of possibilities, and it's up to us to navigate that world responsibly and use this power to solve some of humanity's greatest challenges.
I think that's a great point.
And that brings us to our final thought for our listeners today. We've covered a lot of ground in this deep dive, from the intricate workings of topological qubits to the potential impact on everything from healthcare to cybersecurity.
Okay.
But the real question is, what excites you most about this quantum leap?
Yeah.
What possibilities are you most eager to see unfold?
I think that's a great question to leave our listeners with.
Yeah.
We've only just begun to explore the vast potential of quantum computing,
Mm-hmm.
and the future is ripe with possibilities.
Right.
It's an exciting time to be alive and to witness this technological revolution taking shape.
Indeed. And as always, we'll be here at the Deep Dive to keep you informed and engaged as this quantum journey continues.
Sounds good.
Thanks for joining us for this deep dive into the fascinating world of Microsoft's million qubit leap.